Hi guys, this is another emerald out. So in this there is a chain mass of which is given as 4.8 kgs hangs in vertical plane as shown in the figure. Show that the horizontal component of tension is same throughout the chain. Now if I take any component of the chain, one second, I'll just draw here. If I take any component of the chain, this is a certain component of the chain, and you have tension tangential to the last parts. So say these are the tensions T1 and T2. Then the net force on the chain must be 0. Why? Because it is going nowhere. So there is weight mg, there is vertical component and there is horizontal component. There is vertical and there is horizontal. These horizontal component T1x and T2x, they have to match because the chain is not going left and right, and these are the only forces. So that is what is being asked. Show that the horizontal component of the tension is same throughout the chain. So yes, it will be same throughout the chain. It may be one direction or it may be in the other direction, but the value of T1x and T2x is same throughout the chain. You can take any small section of the chain, any part of the chain, and analyze that. Find tension in the chain at a point P where the chain makes an angle theta is equal to 15 degree with horizontal. So that's a figure given. So we'll just redraw the chain. And again say this is T1 tension, this is at the point A, at the point of suspension. So it has got a vertical component and it has got a horizontal component. I'll call it as T1. So this is T1 cos 60 angle is given as 60 degree over here. So T1 by 2, and this is T1 root 3 by 2 sine 60 at the point A. At a point P again you have tension which is tangential, so it will have TP or say T dash cos 15 degree is in the question. So 15 degree cos 15 degree value has been given, so 0.96 T dash, and it will have a vertical component of T dash sine 15 degree which is 0.25 given, so 0.25 T dash. So we don't know the mass of this much of section. It is some shape and finding the mass is really a trouble. So m dash g in vertical, the equation is not known, but the horizontal one is quite easy. Horizontal one is T1 by 2 is equal to 0.96 T dash. How do we know T1? T1 we can know because another point B is given to us. So horizontal component at B will also be the same, and the whole mass of the chain is given. So we can draw this situation, the whole figure, and here also we have tension, the very same T1 root 3 by 2 and at the point A and T1 by 2, and here we have T2 suppose. So it will have vertical and horizontal component. So the horizontal component this time will be root 3 by 2 because the angle is given 30 degrees over here. So I have not drawn 30 degree, and hence I am not making that. Root 3 by 2 T2, and the vertical will be T2 by 2. Now using the weight of the chain, what we can say is T1 root 3 by 2 plus T2 by 2 is equal to M into G, which is G is 10, so 48 Newton. Using the horizontal component, we can say T1 by 2 is equal to root 3 by 2 T2. So root 3 T1 by 2 will become a 3 T2 by 2. So we can apply this equation number 2, equation number 1. So solving the 2, what we will get is 3 and 1, which is 4 T2 by 2, which is, okay, I'll write it, 3 T2 by 2 plus T2 by 2 is equal to 48, implies 4 T2 by 2, 2 T2 is equal to 48, meaning to say T2 is equal to 24 Newton. So that's your T2. So T1 is equal to root 3 times this. So T1 is equal to 24 root 3 times T1. Yeah, so applying the value of T1 as 24 root 3, which is same in this situation, coming back to this. So my T dash is equal to T1 by 2, which is a 12 root 3. 12 root 3 divided by 0.96 divided by 96 into 100. So you can calculate this. So 12 8 times is that. Root 3 is roughly 1.73, so 173 by 8. So that gives you a 21. 5 by 8. 5 by 8 is 0.48 by 8 is 0.6. So roughly this is your answer for tension. So now they are asking the mass of this section. So this is m dash. So we can make the vertical equation, which is T1 root 3 by 2, T1 root 3 by 2 plus, or in fact minus in this case, T dash by 4, 0.25 T dash is equal to m dash G, m dash into 10. T1 root 3 is 24 into 3 by 2, so 12 into 3. 12 into 3 is your 36 minus your T dash. So you can put in the value and get your answer, right?